Hello students. So from last video we have been doing revision for the test which is going to be held on Sunday. Okay. So basically I have sent you question bank. Please prepare that question bank, and from question bank I am going to discuss some of the questions which might be difficult for you. Okay. So today's question is, we have been asked to prepare these compounds using suitable Grignard reagent. Okay, so we are asked to prepare these compounds using suitable Grignard reagent, but the condition is the initial component is methanol. For all these products, initial component or initial reagent should be methanol. So using methanol, we need to produce or we need to form these products using suitable Grignard reagent. Okay, so let us start the first compound. Okay, so first compound is 2methyl propane 1-ol. Okay, now we need to prepare this compound using methanol using suitable Grignard reagent. So which Grignard reagent is suitable for this product? So for this, as we can see that the initial reagent, that is methanol, has got 1 carbon, whereas product has got 1, 2, 3, 4 carbon. So which means our Grignard reagent should be having 3 carbons. Okay. Now, second thing is our product has got branch, whereas our initial reagent does not have any branch. So which means our Grignard reagent should be having branch. So our Grignard reagent will look like this: CH3, CH3, 3 carbons are there, 1 branch is there, and since it is a Grignard reagent, MgBr is there, or we can write MgCl. And as we already know, Mg is having positive charge and this alkyl group will have negative charge. Okay, whereas in this case, methanol, oxygen will have negative charge and carbon will have positive charge. Okay, now we already know that whenever we are writing Grignard reaction, dry ether is used. Okay, now this positive charge of magnesium will attack on this oxygen. Okay, and this negative charge of alkyl group will be attacked by this positive charge of carbon. So intermediate product will look like this. So HCH. Okay, this alkyl group, or we are writing HCH like this. This alkyl group is negative charge, it is attacking on this carbon. So we will write alkyl group like this: CH3, CH3. Okay. Now oxygen is attacked by MgBr, so we will write MgBr like this. So this is an intermediate product, or we can say that it is an adduct, intermediate product. Now, after this step, we are always writing hydrolysis. So after attacking of Grignard reagent on particular reagent, last step is hydrolysis, and hydrolysis is done with the help of H2O. Now, whenever there is a reaction of H2O, H2 is decomposed into H plus and OH minus, right? Now, this OH minus will be attacked by this Mg because it is having positive charge, so it will form MgOH-Br. Okay, so OH minus and Mg will form MgOH-Br. Now this oxygen is attacked by H plus, so it will form like this. So this is CH2. So this is CH2. This is CH, CH3, CH3. Oxygen is attacked by this H plus, so it will form like this. So this is ultimately what is product 1, 2 and 3. See, like this: 1, 2 and 3. This is 2methyl propane 1-ol. 2methyl propane 1-ol. 1, 2, 3. 2methyl propane 1-ol. So this is our product. Okay. Now for second compound, our initial reagent is methanol only. So this is methanol. Okay. Now we need to form cyclohexyl methanol. So our initial compound has got one carbon. Our final product has got cyclohexane ring. So which means that our Grignard reagent should have cyclohexane. Okay. And one carbon. Methanol has got one carbon. So that question is getting solved. Now our product has got cyclohexane. So our Grignard reagent should have cyclohexane. And since it is a Grignard reagent, it will be having MgBr. Mg is having positive charge, and since Mg is having positive charge, this cyclohexane ring has got negative charge. Whereas in this case, oxygen will have negative charge and this carbon will have positive charge. Now Grignard reaction is there, so we are writing dry ether. So dry ether is there. Now this Mg plus will attack on this oxygen which is negatively charged, and this negatively charged cyclohexane ring will attack on this carbon. So product will look like this. This is positively charged and this is negatively charged. So cyclohexane, which is negatively charged, it will join with carbon which is positively charged. Okay. Now oxygen, which is negatively charged, is attacked by this MgBr. So Mg is positively charged, so MgBr will join with oxygen. So this is an intermediate product, this is an adduct, right? Last step of Grignard reaction is hydrolysis. So we are writing H2O, and as we know, H2O will be divided into H plus OH minus. OH minus will attack on Mg and it will form MgOHBr. So first product is MgOHBr. Mg will attack on OH minus, so it will form MgOHBr. And last product is H plus will attack on this oxygen, so it will form cyclohexyl ring is there. CH2 is there, so this is CH2, and oxygen will be attacked by this H plus, so it will form OH. So this is our product, cyclohexyl methanol. Okay. Now for further reactions, you need to revise videos which I am going to associate with this video. Okay. So if you are asked to form products using suitable Grignard reagent, now you know how to use Grignard reagent.
Discuss is the preparation of alcohols from alkenes by acid catalyzed hydration. Here's the general reaction. An alkene reacts with water in acidic conditions to form an alcohol. This method is used less frequently for lab-scale synthesis of alcohols. If the alkene is unsymmetrical, meaning that different groups are attached to the carbons of the double bond, then two possible alcohol products could form. How do we determine which alcohol will be the major product of the reaction? Marconi-Cogs rule allows us to predict the regioselectivity. The hydrogen will add to the carbon with more hydrogen atoms bonded to it. The hydroxyl group adds to the carbon with fewer hydrogen atoms bonded to it. Let's work through a problem to show the application of Marconi-Cogs rule in acid-catalyzed hydration of alkenes. Propene reacts with water in a dilute solution of sulfuric acid. What are the two possible products of the reaction? Identify the major product. Start by drawing the structure of propene. Notice that one carbon in the double bond has one hydrogen atom attached, while the other has two. Draw the two possible alcohols that could form. Using Marconi-Cogs rule, we can determine that the upper product shown is the major product of the reaction, the H atom added to the carbon with more hydrogen atoms. The lower structure is the minor product of the reaction. It's important that you understand the mechanism of acid-catalyzed hydration of alkenes. We'll go through each step in detail. Step 1 involves the formation of a carbocation. The carbon-carbon double bond becomes protonated to form a stable carbocation. Then, water, acting as a nucleophile, attacks the carbocation to form an oxonium ion. Finally, the oxonium ion loses a proton to water, acting as a loose base to form the alcohol. A second synthetic route to prepare alcohols is by the hydroboration oxidation of alkenes. This can be summarized as a two-step process. First, the alkene reacts with diborane to form a trialkyl borane compound. The series of steps that forms the addition product trialkyl borane is shown here. Then, the trialkyl borane is oxidized by hydrogen peroxide in aqueous sodium hydroxide to form the corresponding alcohol. Note that water is not a reactant in the hydroboration oxidation of alkenes. A particularly useful feature of this synthetic route is the resulting anti-Marconi Cogs hydration of the alkene. In contrast to acid-catalyzed hydration, hydroboration oxidation results in the hydroxyl group attaching to the carbon with more hydrogen substituents. Let's do a practice problem. Draw the structure of the main organic product formed when 2-methyl-2-butane is reacted with diborane in a suitable solvent, followed by treatment with basic hydrogen peroxide. Start by drawing the structure of the reactant. Since this reaction uses hydroboration oxidation of the alkene, the major product will show anti-Marconi Cogs addition. Therefore, the hydroxyl group will attach to the carbon with more hydrogens, as shown here. Another route for the preparation of alcohols is by the reduction of aldehydes and ketones. This involves the addition of hydrogen gas in the presence of a suitable metal catalyst, such as platinum, palladium, or nickel. The overall reaction for the catalytic reduction of an aldehyde to a primary alcohol is shown here. This method also works for the reduction of ketones. Aldehydes and ketones can also be reduced by treating them with reducing agents such as sodium borohydride or lithium aluminium hydride. The overall reduction of a ketone to form a secondary alcohol is shown here. Aldehydes can also be reduced in a similar fashion. Can you answer this question on your own? Give the structure and IUPAC name of the product expected from the catalytic reduction of 2-pentanone. When you draw the correct structure of 2-pentanone, you should immediately recognize it as a ketone, as the carbonyl group is in the middle of the chain. The catalytic reduction of a ketone produces a secondary alcohol. The product is 2-pentanol. Alternatively, you could have used sodium borohydride or lithium aluminium hydride instead of hydrogen gas with a metal catalyst. The fourth route for alcohol preparation involves the reduction of carboxylic acids using lithium aluminium hydride. Carboxylic acids are very difficult to reduce. So this process requires a very strong reducing agent, lithium aluminium hydride. The overall reaction given here shows that carboxylic acids can be reduced to primary alcohols. This is actually a two-step process. First, treatment with lithium aluminium hydride, followed by the reaction with water. Lithium aluminium hydride is actually very expensive, so the use of this reaction is somewhat limited. Since carboxylic acids are so difficult to reduce directly, a fifth synthetic route is used in industrial settings. The carboxylic acid is converted into an ester, which is then reduced. The first step of this process converts the carboxylic acid into an ester. The carboxylic acid is reacted with an alcohol to form an ester molecule and water. Esters are much easier to reduce than carboxylic acids. The ester can be catalytically hydrogenated to form two alcohols. This process requires a specialized catalyst, which is why this process is typically carried out in industrial settings. It's time to try another practice problem. You wish to make a cyclopentyl methanol, shown here, by using lithium aluminium hydride in diethyl ether. Determine the structure of an appropriate starting material. You need to work backwards from the desired product. Remember that using lithium aluminium hydride involves two steps that should be listed over the arrow. An appropriate starting material would be cyclopentane carboxylic acid. Since the desired product is a primary alcohol, you could also start with the appropriate aldehyde instead of the carboxylic acid. Grignard reagents are important in many chemical syntheses. Grignard reagents are alkyl magnesium halides. General formula for a Grignard reagent is RMgX, where R is an alkyl or aryl group. Shown here is methyl magnesium bromide, an example of a Grignard reagent. Grignard reagents provide a sixth route for preparing alcohols. Grignard reagents can be reacted with aldehydes and ketones to make alcohols in a two-step process. The first step involves nucleophilic addition of the Grignard reagent to the carbonyl group to form an alkoxy magnesium halide adduct. Then the adduct is hydrolyzed to form an alcohol. Grignard reagents are useful in preparing a variety of different alcohols. When Grignard reagents are reacted with methanol, commonly known as formaldehyde, the reaction makes a primary alcohol with one more carbon than present in the R group of the Grignard reagent. When a Grignard reagent reacts with an aldehyde other than methanol, the reaction produces a secondary alcohol. The reaction of a Grignard reagent with a ketone produces a tertiary alcohol. Try to answer this question on your own before checking the answer. Give the structure and IUPAC name of the product expected from the reaction of pentanal with ethyl magnesium bromide. Start by drawing the structures of the two reactants. Recall that an aldehyde reacting with a Grignard reagent forms a secondary alcohol. This reaction will form 3-heptanol, as shown here. Let's turn